Hey folks, welcome to my channel Number Pen. So there we have the problem on the screen. Find the derivative of the following: x equal to 1 minus t square divided by 1 plus t square. And then we have y equals 2t divided by 1 plus t square, right? So it looks like we have a parametric equation in place. X and y are connected through t, which is a parameter here. So I will have to figure out what is my dy by dx, right? So let's write down what is our dy by dx first. My dy by dx is nothing but dy by dt, the whole divided by dx by dt, right? Because I have x and y in terms of t, I can differentiate my y with respect to t and then x with respect to t and put it back in my dy by dx to arrive at the final answer. But then when you look at this problem, right, I'm going to adopt a slightly different mechanism to solve this particular problem. And it's something that you folks must be familiar with by now if you've looked at some of the previous videos I've solved, where I've solved problems using trigonometric substitution. And when I see x and y of this type, I would probably draw a parallel to one of the trigonometric identities or one or more of the trigonometric identities that I'm familiar with, tan theta, right? And if I make the substitution t equals tan theta and rewrite x and y in terms of theta, will it simplify my problem? Because when I do a dx by dt and a dy by dt, I've got to apply the quotient rule, and does not look like it's a very complicated quotient rule application, and it's obviously error prone though. But I'm going to try and solve this method using the trigonometric substitution, where I'll do a t equals tan theta, right? And when I make that substitution, right, my dy by dx expression obviously changes, right? Now we'll come to that. It's no longer dy by dt divided by dx by dt because I'm going to put my x and y in terms of theta, right? So my x becomes 1 minus tan square divided by 1 plus tan square, right? So let me write down my x first. And this is a formula which we folks are quite familiar with, right? When my x equals 1 minus t square divided by 1 plus t square, then my x equals 1 minus tan square divided by 1 plus tan square. So I have a 1 minus tan square theta divided by a 1 plus tan square theta. And when I write my tan theta as sine theta by cos theta and then do a cross multiplication, what do I get? So this is what I have when I substitute tan theta equals sine theta by cos theta. I cross multiply the cos square theta in the numerator and in the denominator, and what do I get? My cos square theta post that gets cancelled, right? So I will have a cos square theta minus of a sine square theta divided by a cos square theta plus sine square theta. And this is nothing but my denominator is a 1, right? Because we have the trigonometric identity cos square plus sine square equals 1 for the same angle theta. And then my numerator is a cos square theta minus a sine square theta. And I would expect you to know this particular identity. This is nothing but a cos of 2 theta, right? So there I have expressed my x in the form of theta post making the substitution t equals tan theta, right? And so we have expressed our x in terms of theta, right? And Now I go to my y, and remember you cannot make a different substitution for the t in x and y. The substitution that you make has to be the same, right? Because it is the same t which is available in x and y, right? So my y equals 2t divided by 1 plus t square, right? So there I have y equals 2 tan theta divided by 1 plus tan square theta, right? So let's do a further simplification of this. My tan theta is nothing but sine theta by cos theta. So I have 2 times sine theta by cos theta. And folks, this is again an identity, but in case you have a challenge remembering the identity, it is always useful to express everything in the form of sine, cos, and then arrive at what we want to arrive at. Right? So what happens to this particular expression is my cos theta, this cos theta, how do I highlight it? This cos theta cancels out with the cos square theta out here, but that's after moving my cos square theta through cross multiplication, right? So what do I have? I will end up with 2 times sine theta into cos theta. And why is that? Because my cos square theta's 1 cos theta goes to the numerator after I cancel out. I'm left with 2 sine theta cos theta, the whole divided by a cos square theta plus sine square theta, right? And what is my cos square theta plus sine square theta? It is nothing but a 1. So there I have my y also expressed in terms of theta. I have it as a sine to theta, right? So now I have my y in terms of theta, I have my x in terms of theta. We will go to our dy by dx expression. I'm going to make a small modification. When my dy by dx equals dy by dt divided by dx by dt, now I have connected my x and y not through t but through theta. So therefore my dy by dx can be equal to dy by d theta divided by dx by d theta, right? So now I have my dy by d theta from this expression, right? Because I have arrived at y in terms of theta, so my dy by d theta will be 2 times cos of 2 theta, and that's again from chain rule. And why is it chain rule? Because I have cos, I have a sine function, so I do a differentiation of that with respect to the inner function, which is 2 theta, and then I go to my inner function and differentiate the inner function with respect to theta, so I get a 2, right? So I have a 2 times cos 2 theta. And then I have my dx by theta. When I work it out in a very similar fashion, I will end up with minus 2 times sine 2 theta, right? So this is what I have. So I have my 2 and 2 getting cancelled out. And then I have a minus 1 because of the minus sign. I have a minus cot 2 theta, but I'm going to represent it as a tan 2 theta because I'm quite familiar with representing tan 2 theta in terms of theta, right? 2 times tan theta divided by 1 minus tan square theta. And if you're trying to figure out this particular identity, I'll put a link to that particular video where I have solved for this, right? So my tan 2 theta in terms of tan theta is nothing but 2 tan theta divided by 1 minus tan square theta. So there we have our dy by dx in terms of tan theta, but I'm expected to express my final answer in terms of t. So when I put back tan theta equals t, what do I get? I get a minus 1 times this 1 minus tan square theta goes to the numerator. So I write it as 1 minus t square into minus 1, right? And then my 2 tan theta is nothing but 2t, right? So there I have arrived at my final answer more or less. So this is nothing but, let me go to the next step. My dy by dx is nothing but minus of 1 minus t square is nothing but t square minus 1, right? So I write it as t square minus 1 divided by 2t, right? Is there a possibility to further simplify? The answer is no. Therefore, we have our final answer in terms of t now. It's dy by dx equal to t square minus 1 the whole divided by 2t. I hope you found this content useful. Please do subscribe to my channel and support. Thank you.